So let's come back to and review our discussion last time, the first 8 aphorisms. Those are like building blocks. And then we are going to build houses on top of them by covering the final few building blocks. So the first one was very straightforward, right? If you want to get some good answers, you have to provide good questions. We don't want to spend more time on that. And then the second aphorism is thinking about, well, if you just go for the default behavior of large language models, you get this default behavior of maximum likelihood, right? And the last time we mentioned maximum likelihood will give you the most popular answer from the corpus, from the training corpus, and the most popular one may not be the most accurate one. And sometimes hallucination or maybe biases because caused by majority opinion. Right? So we really want to have objective perspectives, and we really want to have various opinions. And by having those, and in certain situations, we are able to kind of discover something novel. So to achieve that, and I mentioned we have kind of this debate setting, okay? So that was a kind of this aphorism too. So debate setting, we say, well, we position 2 agents, one to stand on the positive side of a subject, the other one just against the first one. The simple setting, the first agent can just using default maximum likelihood, and the second agent just say, well, I want to play devil's advocate, just keep on going ping pong back and forth. But if you're just doing contentious debate, again, we mentioned last time, and maybe at the end, 2 agents just go for each other. There's no concession, there's no actually robust reasoning. And I showed a table last time which saying, well, if you are in very high contentious mode, the LLM may behave as saying, well, whatever you said, I'm going to just challenge you. Or maybe it's reasonable, but it's not implementable, it cannot be implemented, or it's non-ethical or violate the laws. So that's not good. So we say, well, we have to modulate, right? Qualitatively modulate contentiousness from highly contentious to kind of conciliatory. And we also mentioned, which we didn't cover the detail, that was a good qualitative kind of modulation, but nobody will buy in your qualitative research. People will go after you saying, can you quantify this whole process, right? So we did kind of hinted, you can use information theory. There are a couple of very important metrics. One is cross entropy. So suppose you ask 2 agents, you say, don't just give me your opinions, but for healthcare, you can say, give me the top 3 disease predictions. And for the second agent, you can say, give me another 3 different ones. Then you have 2 probability distribution. And then you can start to compute entropy, start to compute mutual information, right? And you want mutual information to increase, you want entropy to kind of stabilize, then you know the debate is going to the right direction. At the same time, as I will show in a couple of slides, we have other agents participating in the debate or discussion. So this is kind of group effort. And finally, we hopefully get some quality discussion. And so always it's a myth. You say, well, you just ask an agent to be contentious. But how come by just asking an agent to be contentious and you will behave contentiously? This is like really strange, right? You say, well, LLM is just kind of predicting the next token. It's an autoregressive model. Why just by saying putting one word, saying, oh, you have to be combative, then you see all the text generated will be kind of very, very aggressive. I actually cannot give you the theory behind it because actually no one knows, right? But this is a picture probably showing the intuition behind it. So if the Earth is closer to the sun, it's warmer in the summer. Otherwise, like right now, it's kind of in between. So what contentious or emotion, later we talk about modulating linguistic behaviors. So when you start to say you have to be contentious, so it's sort of like the planet will be moving to somewhere and maybe a very hot place. And this is like your transformer. It's a very abstract space in very high dimensional space and many, many layers. And you get gravitated to a cluster. And around that cluster will be a lot of documents speaking or written in a contentious manner. So your maximum likelihood in that situation, because your entire writing right now is kind of gravitated to a particular region in this universe. So therefore, in that situation, the writing will be more contentious. It's a little bit abstract, but it's I ask GPT, ask Cloud to say, what did you do? Actually, frankly, they don't know, right? But this is probably one of a reasonable explanation. If you can come up with a better explanation, that would be fantastic. One of the projects I think we will talk about is kind of related to this kind of discovery of what's actually going on within this huge, huge box. Okay, so the next thing I mentioned, saying people worry about hallucination. People always say, Edward, you are doing something I don't believe in, because if two agents can hallucinate, how can they just debate with each other, right? They would come up with rubbish. So last time I say, well, because a bad dream with a slightly different contextual situation, you never have the exactly same bad dream twice. And likewise, in the large language models, the fact every model nowadays using mixture of experts means you have like 8 agents behind GPT-4, and you have maybe 16 behind Gemini. So in that situation, when you make a query, you may go to one of the 8 or 2 of the 8. So not necessarily you will go to the same one. So the process is already stochastic. So if you can do an experiment and come back to show me saying, hey, I have 2 queries, I get exactly the same nightmare, and that will be really great. I'll give you a bonus, some bonus points. Then in debate, it's even harder to repeat the same nightmare because we are the 2 agents providing additional context. And so far we are seeing in the beginning of debate, you kind of improving perspectives, improving breadth. At the same time, reasoning, improving depth. So the space for hallucination is not only different, but also get constrained, right? Because you have much more content. And just like, well, I'm ordering pizza, but now I'm telling you this pizza is this afternoon need to be delivered and has to be the pizza has to be delivered to my Palo Alto home. So it's much more specific around say, oh, give me a pizza. So I have no idea where you are. So I think this is sort of like observation again, but the intuition is still quite critical. So I haven't seen my own experiments having this hallucination repeating, and even more encouraging is in the second or third round of this debate, you don't actually see nonsense. You do see people an agent may insist their own opinion, kind of repeating the same arguments again, but you don't see they alter something which is totally out of the blue. So that's good. So again, I say, well, multiple agents involved, and so far we only talk about 2 debaters. But then you can see this picture, we also have moderator. The moderator, as I said, right now qualitatively, a human saying, oh, be contentious or conciliatory, but we replace it to be information theory, right? We just gauging the entropy between cross entropy information, mutual information. Also, you can maybe use the other distances like KO divergence if you know information theory. Then we have judges, and judges, I will get into some more details. Judges trying to evaluate the quality of the debate. And the next aphorism will say, what do you mean quality of debate? There's no truth, as we mentioned. There's no absolute objectivity in this word, right? So how do we measure quality of debate? We use reasonableness. So again, critical thinking, we have to have quality evaluation. The process I've already said about, right? That's good. And validation, we haven't talked about, but later in aphorisms 7 or 8, we'll come back to talk about self-validation. And the next aphorism is about emulate human behaviors. As I mentioned in the last lecture, I say, well, lots of people still consider LLM is a black box. But I think Russell, a professor in Berkeley, came over to, we had a discussion that he actually said, well, I totally agree with, we use a lot of billions of documents to train the LLM. So every document is written as a human, we have purposes to generate certain documents, right? Writing a diagnosis or writing a love letter to the loved ones, or write an essay, write a papers. Then we use linguistic patterns. We use certain content to kind of support our objectives. So you can say, well, when LLM return the answer to you, it's kind of understanding your objectives right now, your questions, understand the context, then it kind of play out using some behavior, linguistic behavior, or actually even emulating emotional behavior, then give you a piece of writing. So again, no proof, but I think over and over again, this has been shown to be just there. So I used a couple examples last time to demonstrate, and one was straightforward, right? You start with very contentious scenario in the beginning, and this is leading nowhere, for sure. This is 100% contentious debate, and there's no results. And then you have this kind of debate, right? This kind of maybe 90%, and eventually you kind of saying, well, you are getting nowhere. The debate quality is not good anymore. Mutual information is not improving. So let's sit down, be calm, and kind of conceding to each other's reasonable arguments and be conciliatory again, and then we can reach some common ground. Here, again, the result may not be truth, but the result of the debate is good because you're unearthing all different perspectives and present to the human in the loop, and all different perspectives with all the supporting reasons, all displayed in front of the person, right? The person wants to see the results. And I don't repeat it, but this is how LLM tells us, they're saying, under different contentious level, and it produces so many documents. I gave LLM back all the documents. This is self-supervising learning. And then ask LLM, what did you do on the different contentious level? And this is the table it prints out. It's really kind of mind-boggling. And it doesn't know what it's doing. And it's just like, you see that this movie actor or actress, when they place a role, which is in a very sad situation or happy situation, they are not really sad. They are playing to be sad. They are emulating the sad mood. So, like it or not, some people saying, wow, GPT or LLM faking reasoning, right? GPT faking emotion. Okay, actors faking emotion when they play a role. So, do you not going to see a movie because they are faking, all people are faking there? I don't know. This is a very interesting argument because when Lucan say, oh, it's faking, and other, as well-known people will say, what's the point? Philosophically, the same thing, right? Maybe we are faking too. We don't know. We are driven mainly by our unconsciousness, which I will talk about at the end of the lecture of my part. So I also showed last time this emotion using this kind of diagram, different spectrums of emotions, and you have negative and the positive on every spectrum, and this is a good way to kind of using real number, you can slide from one end to the other. It's much easier. As I said, two benefits. One is you can start to do gradient descent. And second thing is you don't have to worry about which words should be between these two words. I couldn't come up with any of them. I mean, if you get asked, what's the middle word between interest and anticipation? We may have a huge debate here. So forget a bit. Just have some 7 is already pretty crowded. Okay. Then I show that GPT is able to understand what we are saying. We say, generate a picture with a lady in a garden, and with 7 different moods. I didn't print out the neutral one, but then this is kind of remarkable. I was surprised GPT was able to understand what these different emotion means and can actually draw those pictures. You can see the background and also see the lady's face. So here again, I just repeated the intuition I presented. It's like, oh, I say, I want to write something which is kind of sad and maybe a mixture of feeling of kind of hope in the end. So then you are conditioning your planet to somewhere in this universe, in this space. You can move to close to a cluster or multiple clusters. And then the next word generation, this auto-regressive algorithm, will give you the results from that particular cluster. And that will be the distribution be utilized for the next token prediction. So at least I think, although we don't have proof, that story so far will make me a little bit comfortable because I say, oh yeah, I'm not dealing with just totally nothing. So whenever you folks can think of other methods or other kind of metaphor to kind of describe this phenomenon, for sure, let's have a discussion. Yeah, this is really interesting. And I don't know whether we can see in someday this whole entire thing can be interpretable. That'll be pretty nice. But so far, like Perplexity, the company is able to, they try to trace, suppose you generate a document, they will be able to try to trace where are the source documents supporting this answer, right? And DeepMind also started doing a research about 2 years ago. The paper title is Mining a Needle in Haystack. But they confessed that the entire process was not scalable. So basically they trained a very small model with just about 10 million documents. And when you ask this particular small model to generate a piece of document, it can trace back to find the source documents. But the computation is exponential. It's really expensive. And it's just 10 million documents. If you get into 1 billion, whatever, this is going to cost you maybe a year or two to get the bottom out of it. Please.
Do you know if they're looking at the vector embeddings to be able to trace back, or do they have some other type of retrieval indexing system to be able to?
I don't know the details, but seems like they using this vector or whatever, just going all the way down to see whether they can eventually kind of trace, with some probability they can trace to the source documents. But I think maybe we can look at.
You can embed all the documents pages, like just like what you're doing when you build a vectorized database, and then of course when you have the answer, you can look at those embeddings and match, only get the best match, I guess.
Yeah, but I think Pauline will talk about a project maybe you guys will be interested in. But that one was to detect plagiarism. Yeah. So I myself had a bad experience because I put my book in the public domain. And why did I do that? Because I published the first version March last year and published 3 different versions. This paperback, hard copy, and also this Kindle version. But just in a few weeks, my Kindle version was converted to PDF and was kind of displayed on one of the websites. So this was nothing I can do about. So I decided to say, okay, stop publishing the Kindle version, and I open source because I keep on updating my book. And after you open source, of course, it can become a piece of training data, right? And then if you have another researcher trying to write a paper about, oh, give me some ideas of what are the top important issues, and we should do research upon LLM, then there's a possibility my content will be borrowed, right? So I actually ask GPT and Cloud to do a thorough analysis, and I publish on the web to say, what's the probability it's a plagiarism? And the probability actually pretty high, but I try to be diplomatic in that particular website. I didn't say, I said just excessive borrowing. Right? But it would be nice to be able to trace these kind of things. Because this academia is going to be facing these kind of challenges in the future, right? So, big problem. Okay, so definitely this is not the end of the story. We come back to visit, and maybe if you are interested, maybe Pauline's project will be going into that direction. I personally think that's a very important endeavor. Right? And nowadays, like I never say don't use LLM to do your homework, because that kind of requirement is just useless, right? So you take advantage of LLM, but just when you publish, and you have to really worry about you don't do this kind of unintentionally borrowing, because once you have done that, like the paper sort of borrowing my content, there were at least 3 very famous professors on the list, and their reputation may be down to the tube. So this is kind of things is extremely dangerous. Okay, so we go to the aphorism 6, and this is not just my opinion, but if you look at the literatures or philosophers, they would say, yeah, in this universe, there is seldom truth, right? Geometry may be truth, but only until aliens can travel using geometry property to reach the Earth. But you don't know whether geometry is truth locally on Earth or is universal truth. I have no idea. You have no idea. So most of the scenario is kind of relatively true on Earth. But even on Earth, we have a lot of things. Majority, we have different opinions. Each of us can be subjective. So on and on and on. It's just impossible. So in that situation, the only thing we can do is reasonableness. And this is an algorithm to deal with reasonableness. And it looks very simple, and it's in chapter 4. So basically, when we were like a child and we were in school, and I think the first way to train us to do critical thinking is to do critical reading, right? So we cannot say, wow, 1 year old, start to think critically. I mean, we get some training when we were maybe in the kindergarten or preschool. Okay, this is a document, and try to analyze it and tell me what is the subject of document, what is the conclusion, and give me the supporting reasons. And are the supporting reasons strong or weak? So basically, given the document D, and you can just say, oh, I want to analyze this document. Eventually, I want to output a score, whether the document has sound reasoning. And we have a few variables here, right? So first thing I do here is identify in D the claim statement. If a document is well written, the claim statement has to be there. Like you have experience writing papers, you know, all the publication, all the conferences will require you to state what are your contributions. If you don't even state your contributions, your paper is dead, right? The reviewers are not entitled to look for your contributions. You have to give it to them. So, okay, this is not really hard to find unless it's a wishy-washy paper, then it doesn't matter. And then find a set of supporting reasons to support this conclusion. Then for each of the supporting reason, then you can form this kind of entailment. This reason supports this conclusion. And then you can say, well, now you can evaluate whether this is solid or not, right? Suppose you say, oh, in preschool, you have TV showing advertisement to the kids. They are confused, right? They are tempted. And you have supporting argument saying, well, they may get into trouble because they have no way to evaluate something is real or not real or something like that. So then you say, okay, if that's a reason and your conclusion is, yeah, you should ban those kind of ads, then we evaluate whether that particular reasoning is solid in 2 terms. One is whether the reasoning itself, next slide will show in terms of inductive reasoning or deductive reasoning, and we can evaluate whether the reasoning is sound, and you can get a score. Another one is where did you get the source? So source credibility, right? In Google, source is easy to find because the higher ranked pages is considered to be pointed by many other pages. So we consider credibility shouldn't be too bad. And also we trust Google kind of screening the bad websites. So credibility and also the reason soundness may not be too hard to evaluate. It may not be perfect, right? But qualitatively, this is probably good enough. And then there's a subtle thing is, if a reason is a claim, so you say, oh, I support this treaty because he also supports it. No. Then you have to go this kind of recursively going to the other person's claim I borrowed and to see what are the supporting reasons for that person to claim that conclusion. And at the same time, in the debate, it's perfect because we have two sides. Not only one side has argument, you also have the other side doing counter-argument. So we are getting also counter-argument and analyze every one of them using this same methodology. At the end, you have a side-by-side comparison. For the pro side, for the con side, each argument, right, each reason entails the conclusion. Conclusion is extremely clear. One is pro, one is against. And this is so clear, right? This document is after the debate, this document is so well written, and this algorithm will work reasonably well. The only thing you may argue saying, oh, how do you quantify reasonableness? So I talk about source credibility. And sometimes you couldn't get sources, and that's too bad. But sources, we have to maybe borrow external APIs. Like last time, Leonie was talking about, you have this agent land graph. You can call out to external API. You can probably do a search and do some references. And how about logic quality itself? So we mentioned about Socratic method 1 to 7, and each one of them, you have time, you can look into details, but most of you probably don't have. I spent about 3 months. I took a course in continuous education to figure them out. And each one of them you can map to formal reasonings. And then you get the tools. All the tools, you know, the deductive reasoning, you don't need tools. You know A entails B, B to C, then you know A to C is truth. But inductive reasoning is just statistics. You have to just do supervised learning. You get a lot of training data. You do all those things. But then my question is, when you want to evaluate your reason quality, do you go out to write your own machine learning algorithm, or you just trust LLM? So my thought, this was an interesting debate with my colleague about 2 years ago. My thought was, you cannot do better than LLM, right? If you go out to collect your training data, unless LLM doesn't have that particular set of knowledge, but if LLM has general knowledge about physics, and now you say, oh, I'm going to train another evaluator for physics exams. No, first of all, it's very time consuming. And number two, you may not get something much better than LLM itself, right? LLM is already a kind of general purpose QA system. So I would incline to say, forget about doing everything by yourself. Just trust this end-to-end system. As I said it, the first lecture I gave a couple examples, which we can repeat them today, was like when Demis was here, DeMai CEO, right? He gave a couple examples about AlphaGo itself, compare AlphaGo and with AlphaGo 0, and AlphaGo 0 performs much better than AlphaGo. And he also compared AlphaFold 1 with AlphaFold 2, and AlphaFold 2 wins over AlphaFold 1 by a huge margin. And the lesson learned was, in AlphaGo and AlphaFold 1, there was a lot of human heuristic built in, right? Using AlphaFold, because last time I talked about AlphaGo, but this time let's talk about AlphaFold 1. AlphaFold 1, you do protein folding, and after you get this a sequence of atoms, right? If you already have some ground truth, you know the resulting structure. And what the engineers in in DeepMind was saying, well, the structure, if I can see the structure, there's no reason I cannot, using 5 degrees of freedom, to describe the structure. Because the structure has a number of atoms, right? I know the distance between any pair. I know the angles between them. So why not I can just build a table. I build a column and rows. All the atoms in both column and rows, their relationship, 5 degrees of freedom, it's all done, right? There's no way you can think of the six axes or 6 dimensions. And so they use that as the ground truth. Then they train their predictor, and the score was wonderful. They probably beat the previous comparator by a huge margin. And Demis was saying, well, you know, the second one, when we do this AlphaFold 2, we basically say, hey, get rid of this table, right? It's really painful. You guys don't want to because you spend so much time to encode it. But get rid of the table. The accuracy boosted from 49 points to 91. So what can you say? So human consider, we saw the structure of atoms. There's only 5 degrees of freedom. There's nothing more than that. But maybe computer vision, just using your cameras, and then you do this kind of neural networking, CNN, whatever. It has extracted certain features we don't even understand, we don't even know. And then the result get much better. And this has happening in this computer vision for the last more than 10 years. The contribution of ImageNet was, once you have this large set of data, rather than having computer vision professors trying to figure out what kind of features to be extracted, and they said, no, just give me the ground truth label, and then you just ask this CNN to just learning all the parameters, and then you do prediction. If the training data tells you, oh, prediction is wrong, you come back to do back prompt, and adjusting all the parameters. At the end, the results are much better, right? There's no dispute. ImageNet plus AliceNet, and convinced a lot of companies to invest in GPUs, right? A few years ago, if you use a lot of GPUs in your company, people consider, like I gave you the story, people consider when I was at Google, you are stupid, right? You don't do that, but now everybody is kind of in nature doing such. So, human in the loop, in this kind of situation, is only counterproductive. So this is kind of sad. So, but then I'm happy to come back to CRJ. Yeah. Don't do it by yourself. You just rely on LLM to do this judgment. So I would say this crate algorithm itself is good enough. And if you can find out ways to improve it, great. But I think the flow, depending on LLM to do reasoning assessment, is cool. So those are the examples. The last one I haven't given to you, but those are examples enumerated by Demis. And he's the CEO. He knows all the experiences. So we have to trust him, right? And polydisciplinary, I mentioned last time, because when transformer try to be adjusting its parameters, it has no idea about the domains of every single document. So it just gives you this poly mixture of all disciplines together, one representation. And only when we ask questions, we know we are asking physics question, we are asking computer science, and then maybe because of the planet picture, right? We ask a question, and some people saying, "Oh, LLM cannot be AGI because LLM doesn't have ontologies." Do you really need ontologies? Maybe not, because when we started to ask the question, saying LLMs, right? What is auto-regressive algorithm? When you ask this question, LLM somehow will gravitate to computer science, AI, and finding those clusters of documents, start answering the question. Yes, it did not have ontologies, but it didn't prevent LLM to find the relevant nest tokens to answer our questions, right? So, hey, the requirement of ontologies become moot. Right? So, okay, this is an example saying, well, if I'm 10 years old, standing in the middle, try to interview all those Nobel Prize laureates, no way I can ask any intelligent question. I'm going to waste everybody's time. It's a joke. So the only way to be able to, from this polydisciplinary representation, to find something which is unknown, right? Majority of things in the universe to us is unknown, 99%. We don't even know their existence. Then how can we even formulate questions? There's no way we can formulate questions. So you can trick them by ask them something very simple, but at the same time you sit back. You don't want to get involved, because when you get involved, every time you say something, it's going to move them to different spaces of the universe and just kind of counterproductive. So this is an example. I did it myself about a week ago, and was just for fun. So we talk about, we are solving these LLM limitations using multi-agent, right? So we said, oh, those are the problems we need to solve. I don't want to repeat it, so you can just review them at home. Then I say, well, now I ask you to do one thing. Don't use computer science methods to solve it. Using other disciplines, I didn't specify which ones, but I say maybe biology, maybe whatever. Because when I'm asking a question, it's hard for me to say, using non-computer science discipline to solve it. Actually, that was a question I asked. And it started giving me some like biology, chemistry, and so on and so forth, and eventually give me actually more disciplines. But still, it's kind of conveyed to me using these non-disciplines because LLM may know me, I'm a person, so when LLM talks to me, you should use English, shouldn't use some gibberish kind of unknown stuff. So that's good. At least I think we can communicate, right? And if LLM doesn't say biology but saying something else, then I can understand. So that's good. We can communicate. So LLM actually suggested you can have biology view, physics view, or economics view to try to tackle this problem. And I say, okay, give me more details. And then I kind of reading all those things, I start to say, I don't know the terminologies, whatever. So I'm going to play what LLM teaches me.
In designing multi-agent LLM systems under the MACI framework, we draw rich analogies from biological systems, particularly the human immune system. T cells play the role of validator agents. Just like T cells identify and respond to foreign invaders, validator agents in MACI detect logical inconsistencies, hallucinations, or ethical violations. Helper T cell analogs coordinate system-wide responses, while cytotoxic types trigger correction or rollback. Dendritic cells serve as sentinel agents. These detect new or unusual information and alert validator agents, similar to surfacing anomalies or out of distribution prompts.
I post a lecture.
B cells in designing.
And the second example is in the book, chapter 14. I asked two LMs. At the time was maybe GPT-3, I don't remember. I basically say, well, there's a famous tale in the Bible, Adam and Eve story. And can you start to explore different ideas around it? So to the first one, both agents saying, well, this story, there are many similar stories in different cultures. So he gave me an Indian story, he gave me a story from Greek, open Pandora's box, right? It's really similar, saying, hey, don't eat the apple, don't open the box, or disaster will happen. So I think, wow, intriguing. I saw many interesting stories, relevant stories. And eventually you just branch out, and finally they are talking about this human polluted world, Earth, right? We have this a lot of problem, global warming. It's really similar to the Paradise Lost situation. So I found it kind of intriguing because I didn't give them any instructions to go where and there. And then at the end, the essays got written was both logical and both very insightful, right? So you can try that. And I was encouraged myself to write a novel too. I put two characters together from two different novels and asked them to play out something. And the plot was very interesting. And I actually encourage you to, maybe you can formulate a group of agents, each one you give it a persona, and also the history, characters, a lot of things, right? You can say, well, just play the character of President Trump, okay? And then another one maybe play other things. And now these two people are together on a bus. Just emulate their conversation. So we talk about the debate, means it's kind of in this kind of flat space we can conceive, right? We are people talking together or agents talking with each other. And now we are getting the rest of the 3 or 4 aphorisms are getting more into the insight into our brain. And so this is a Freud mental picture. We have divided this mental state into 3: consciousness, subconscious, and unconsciousness. And subconsciousness is where memory resides. Okay, this is a very simple picture, and different from some people printing out the entire picture of the brain structures, and it's not really interesting. There are 2 ways to tackle neuroscience and psychological problems. One camp is called panpsychism. Panpsychism means you need to know every element of the brain. Then you can start to maybe build intelligent beings. And the other camp is where I'm more believing is it's called functionalism. So as long as you can build intelligent functions, and that's good enough, you don't have to mimic the human neural structure or brain structures, right? So this is a reasonable abstract. So the 8, 9, 10, 11, basically building around this structure, we're going to talk about different measures. So the first one is impulse control, right? So thinking about unconsciousness is really built up in billions of years. And it's manifested from our DNA. When we were born and the DNA started to build to wire our neurons, build our muscles. And as I mentioned last time, we have quite a few very critical functions were supported, were given us as gift. Any one of them missing in our body, we are dead, right? Like heartbeat, metabolism, and breathing. And we cannot learn, we cannot adjust. And they are given to us. If you stop any of them, you're gone, right? So don't be unappreciative to your unconsciousness. And then when there's a dictation situation, when something unexpected happens, then our consciousness will get involved. And I'll give you the mechanics behind it shortly, okay? So let's start with our behavior. So unconsciously or habitually, we have certain behavior. But when you talk about AI ethics alignment, so this is a little bit different dimension, not just debate, but ethic alignment, we are talking about we want to correct people's behavior, right? So someone just like to kind of browse pornography or do hate speech, we say, well, that's not good. And then we have been using reinforcement learning with human feedback to solve this problem, right? You see hundreds of papers out there, but I say, well, it's not really working. Because this is like, I want to train my kid to have this tidiness behavior. And then if my training method is just like the way I was trained when I was a child, whenever I put things in different places, my mother would just hit my hand. And this is like a mode, right? Oh, don't do this and don't do that. So yeah, maybe I was able to correct my behavior to make my study room more tidy, but it doesn't actually generalize to my other untidy behavior. Like I don't make my bed or whatever. Right? So it's like overfitting certain things. And if you do this kind of feedback, and there are so many different users coming from different culture, and then there are two things. One, we have different cultural norms, and number two is we are subjective. When you have different raters to try to give feedback of the system, certain feedback will be conflicting. So you are getting kind of average feedback. So a few problems. One is conflicting feedback through this reinforcement learning with human feedback. And then you have this, they call catastrophic forgetting effect. This has been documented in many places. So if you do reinforcement learning with human feedback, too much, then the original powerful skills of LLM get degraded. And if you look at, you just search on this particular term, and you see a lot of people complaining the coding skills of GPT-4 getting worse and worse because you are trying to make GPT-4 backproc all the kind of complaining from the users. And okay, yeah, LLM tried to behave nicer, but then the parameter got changed, so the multiple coding skills get kind of lost a little bit. So that's a problem of, let's say, I was not tidy at home, right? Just thinking things are piling here and there all the places. But I always argue I have this powerful 4D kind of tidiness paradigm. I can find everything I put anywhere, right? But my family will not agree. They say, well, it's just a mess, right? But this is a situation you say, oh, if I follow my family rules saying I need to be very tidy every day, then I'm not going to be creative anymore, right? Because I'm watching out my room maybe every second or so. There's no places for me to really working on my unconsciousness. Why am I saying working on my unconscious? I will talk about it shortly. So this wagging a mole is not productive. At the end, you're just destroying the whole machine. This is not good. So I'm still kind of wondering why people still work on this paradigm to do AI alignment. And hopefully one of the papers, these three branches of government, we receive good reviews. Hopefully that will get in. That'll be a good news. So people may change their paradigms in the future. So checks and balance. And so this is the way we suggested to do ethic alignment. So basic idea is like you have government has three branches. They try to make sure you don't have one branch to be extremely supreme and powerful, right? That will derail this entire democratic system. And so in our case, we say, okay, to avoid this side effect, you backprog affecting the optimum parameters, we are not going to touch LLMs themselves. So we treat them as exactly branch, right? Just give me your knowledge, but we are not going to backprog anything into you. But we have another two elements. One is Dike, the other one is Ares. Those two are dual in Greek mythology. One is like a very fair judge. The other one is probably a troublemaker. So the idea was you can have independent legislations, constitutions, showing what can be done and what cannot be done. Then you have Ares on the side saying, oh, forget it. This is a different situation. This bad thing happens, but we have good reasons. Should be forgiven, right? It's context-based evaluation. Or, oh, don't drink anything, don't drink alcohol. But no. In the U.S. it's okay. So in Europe, right? Like one time I was on an airplane flying to Europe. I saw a teenager drinking beer on the plane. I reported to the airline servant, and they say, European, the law is different. So shut up. So that's Ares, right? Cultural, there are different cultures. You don't have a universal situation. But if you do reinforcement with human feedback, you only have one rule and imposed to everyone. That's just not going to work. So are you convinced logically this should be the structure doing the ethic alignment? Shouldn't be reinforcement learning with human feedback? Okay. The next one is this foundations and adaptation. I only have time to tell about this critical idea. What is unconsciousness? I already alluded, but how the two states get transitioned in our brain. So this is an example. Well, hopefully after this example, you can pretty much comprehend it. So consciousness in evolution, we are unconscious only whenever we want to learn something new and we want to adapt to environment, something unexpected happen. We cannot use our habitual or automatic kind of reactions to deal with the situation. So we, like for example, a child learn how to walk, how to balance the body, and they learn how to bike. And first time you come to Stanford, you don't know where to go. You have to have a map, right? Then we adapt to everything, and everything becomes habitual. When everything becomes habitual and repetition, they get written into your unconsciousness. So if you are interested in playing tennis today and try to start kind of practice tennis, there's no hope because all your muscle memories were not built, were not written into your unconsciousness. So it's too late for you to do that. Likewise, all the music instruments is the same. So like there's a very famous psychiatrist, Jordan Peterson, saying, the most important things to teach a child, you have to teach the child between 2 years old and 4 years old is how to interact with people. Yes, but starting now, no, too late. You have to do it in 2 to 4 years to build in and writing those kindness, whatever behavior into unconscious level. And so now if you I walk right here. I have no notion whatsoever about balancing my physical body. So it's reflexive, right? But then when I walk to the classroom, a lot of time I don't need to worry too much about my balance at all, biking to Gates and drive to Stanford. Sometimes I want to actually go to Costco, but I actually end up driving to Stanford because I thought this was my routine. This must have happened to you, become kind of habitual. But when unexpected things happen, like you ride a bike, there's an unexpected pedestrian shows up, then you have to be switching to this consciousness. Otherwise, accident will happen. And this whole process can be well explained by Schrödinger's quantum jump. And this was written in Schrödinger's famous book, What is Life? And I spent about a year to thoroughly understand the book and translate it into Mandarin.
Consciousness arises from complex brain activity, not really a single quantum jump. But Schrödinger uses the term as a metaphor to describe the situation of when enough energy has been accumulated in the unconscious state, and there can be a trigger of jumping to the conscious state. And this description may not be agreeable to neuroscientists, but quantum theories still believe this is a situation. And especially philosophers who consider this metaphor to be very vivid and also insightful.
It works. And in CNN, we also have something like this. We have this sigmoid function to ReLU function. When the energies or if neurons get sufficiently accumulated, boom, the next neuron will be fired. So we have been borrowed these ideas. So how we transition from conscious to unconsciousness, and those are my experience listening to music, then I fall into sleep, and driving experience, a route, it's an old route, I just have no idea what's going on, and emotion, we cannot be sad forever, right? You just think about it. Don't do stupid things because sadness will not happen forever. Sadness will go away. And this is because the second law of thermodynamics. And in this closed system, in the beginning, the particles will probably be on one side, and entropy is low. But eventually, this closed system, the particles will spread all over the places. The entropy will be peaked. And then the system will become inert. Inert means the system is dead, right? So when I'm listening to a music that starts to doze off, means, yeah, I'm not paying attention. The consciousness of that particular matter just go away. Okay. So again, don't do foolish things in your life because sadness will not last forever. And I think we get probably stop right here because we really want to be able to discuss our projects. The last one is the mind is your own mirror. This is about self-reflection. We talked about the first time and second lectures. You cannot use the same LLM thread to inspect yourself. And just read the book chapter number 15 to gain more insights. We have to have two independent threads, like a mirror. You have to look at mirror to see what's going wrong. Like today when I walk out, I have to take a look at the mirror to see whether I wore my clothes right. So this is just a metaphor to say validation has to be performed by an independent agent. Then the final one is just put everything together. It will be nice when we start to have debate next week. What are missing, maybe? Or this whole thing I have just presented is just totally ridiculous. Let's get into details next time. And the remaining time, I'd like to say, well, we should discuss our projects and like to have our CAs to come up. We do have a list, right, already provided. And if you are interested in certain projects, just let us know. We can even we can sign up a Zoom meeting, or you can come to office hours. And then each CA already kind of dive into certain projects, and they would like a couple of projects. And I said there's no projects important or not important. Every project can lead to good publications. So that's it for my lecture. And yes.